Hello again, everyone, and welcome to another video lecture for Psych 370. In my last video lecture, I talked about the PREMAC principle, right? Which basically just says that reinforcers are behaviors, not stimuli, and that more probable behaviors can reinforce less probable behaviors. So if you let a person or an animal choose how they want to spend their time, then the behaviors that they tend to engage in the most would be what we'd call their most probable behaviors, right? And again, according to the Premack principle, more probable behaviors can reinforce less probable behaviors. So I talked about the Premack principle in my last video lecture, in the one about relative value theory. But like I told you at the end of that video lecture, it's possible to violate the Premack principle. So sometimes a less probable behavior can actually reinforce a more probable one. And guys, that's especially likely to happen if the person or animal has been deprived of performing that less probable behavior as much as they typically would. So, for example, let's say that I'm interested in your TV watching behavior. So, I first do a sort of baseline observation period where I record the amount of time that you spend watching ESPN and how much time you spend watching the Discovery Channel. And let's say that you spend about twice as much time watching ESPN as you do watching Discovery. Maybe you spend 2 hours per day watching ESPN, but only 1 hour per day watching the Discovery Channel. So, what I'd conclude from that observation period is that watching ESPN is the more probable behavior for you, right? Because that's what you spend more time doing. But now let's suppose that I set up a contingency for you where after you watch ESPN for a while, you have to watch the Discovery Channel for a while. So you have to follow ESPN with the Discovery Channel now. Well, based on the Premack principle, what I'd expect to result from that contingency would be that you'd start watching less ESPN, right? The less probable behavior, watching Discovery, should punish the more probable behavior, watching ESPN. So I'd expect you to start watching less than your usual 2 hours per day of ESPN. And you probably will do that if that contingency that I've set up for you is a one-to-one contingency. So, for example, if I've made it so that you have to follow 10 minutes of ESPN with 10 minutes of the Discovery Channel, then yeah, you'll probably watch less ESPN as a result. But suppose I make it more extreme than that. Suppose it's not a one-to-one contingency. Suppose I make it so that you've got to watch a whole hour of ESPN before you can watch 10 minutes of the Discovery Channel. Now, remember, according to your baseline TV watching behavior in this example, you prefer to watch about twice as much ESPN as you do Discovery. 2 hours of ESPN, 1 hour of Discovery, right? Well, now I'm forcing you to watch 6 times as much ESPN as you do Discovery. So, what I've done here is I've deprived you of your usual access to the Discovery Channel, right? So now, if you keep watching the same amount of ESPN as you did before, if you keep watching ESPN for only 2 hours per day, then you're not going to get as much Discovery Channel time. You'll only get 20 minutes of Discovery instead of the hour that you'd typically prefer. So, what you're likely to do in that situation is increase how much ESPN you watch. You're likely to watch more than your usual 2 hours of ESPN because that way you'll get closer to your usual hour of Discovery. And of course, if that happens, then watching the Discovery Channel will have actually reinforced watching ESPN. Since you were deprived of the less probable behavior, watching Discovery, engaging in it became a more precious commodity for you, so to speak. And because you only got to engage in that behavior after you engaged in the more probable behavior, watching ESPN, that more probable behavior actually got reinforced. It got strengthened. It got increased by a less probable behavior. But remember, according to the Premack principle, that shouldn't happen. So again, that's why I said at the end of that last video lecture that it's possible to violate the Premack principle. And again, that's especially likely to be the case if access to the less probable behavior has been restricted in some way. So, let me tell you now about some actual research results that are fairly similar to what I just described with that ESPN and Discovery Channel example. So, guys, what these researchers, Allison and Timberlake, did first was they took some rats and they gave those rats free access to two different water bottles. Okay. So that was the baseline period, right? They're just observing these rats to see how much of each one they drink. One of them contained plain water and the other one contained sweet water. And they found that these rats preferred the sweet water by about a 7-to-1 ratio. So they licked that bottle about 7 times for every one time they licked the plain bottle. So when they were free to choose, that's how they distributed their licks. They drank from the sweet bottle about 7 times as much as they drank from the plain bottle. But then the researchers set up a contingency where the rats had to lick the sweet bottle 10 times before they could lick the plain bottle once. So, kind of like I described in the ESPN and Discovery example, now the researchers are imposing a 10-to-1 ratio of sweet licks to plain licks. And again, that's greater, that's more extreme than the 7-to-1 ratio that they exhibited during the baseline phase. So, if the rats only licked the sweet bottle with the same frequency that they had during the baseline phase, then they wouldn't have gotten as much of the plain water as they had before. And the results of the experiment were that the rats did increase their rate of drinking from the sweeter bottle in order to get more access to the plain one. So, again, drinking from the less preferred bottle, performing that less probable behavior, was able to reinforce the more probable behavior of drinking the sweet water. So, to accommodate results like that, Allison and Timberlake proposed a revision to the Premack principle that's come to be known as response deprivation theory. And guys, according to this theory, it's not the relative values or the probabilities of two different behaviors that really matters. Instead, Allison and Timberlake proposed that a behavior is going to be reinforcing to an animal whenever the animal has been unable to perform that behavior at its normal rate. So the theory predicts that if you've been deprived of doing something as much as you normally would, then the opportunity to perform that behavior will be reinforcing to you. So, guys, in other words, a key idea when it comes to this theory is that any given animal has a desired baseline rate for all sorts of behaviors. Okay. It has an ideal amount of eating that it would like to do, an ideal amount of drinking, of running, of having sex, and so on. And that desired baseline rate, that optimal distribution of behaviors for that animal, is called the animal's bliss point. Okay. And according to this theory, anything that allows the animal to move closer to its bliss point is going to be reinforcing to that animal. Because again, it wants to get as close as possible to its bliss point. It wants to divvy up its behaviors in a way that comes as close as possible to the ideal distribution of behaviors that represents its bliss point. So, just like Premack pointed out, it's important to observe the animal first, right? It's important to watch what the animal does first when it's free to choose, when its behavior isn't being restricted in any way, because that allows you to figure out what that animal's bliss point is. So, let me give you an example here of how bliss points can affect behavior according to this theory. So, let's say that we allow an animal to engage freely in two behaviors, which we'll just call A and B. And let's suppose that during that initial baseline observation period, the animal performs response A 50 times and it performs response B 150 times. So that's its bliss point. It wants to make response B 3 times as much as it makes response A. When left to its own devices, that's how this animal is going to spend its time. So, what happens if we put it in a situation where it can't actually attain that bliss point? Well, according to response deprivation theory, it's going to compromise, basically. It's going to behave in whatever manner it needs to in order to get as close as possible to its bliss point. So, for example, let's say that we establish a one-to-one contingency for this animal, where it's got to make one A response before it's allowed to make one B response. So normally it wants to make three B responses for every one A response, right? So here's its bliss point over here. That's how it would like to divvy up its responses. But it can't do that now because we're requiring it to make one A response before it can make one B response. So that one-to-one contingency that we've imposed on this animal is represented by this straight diagonal line on the graph. And guys, what response deprivation theory predicts is that when it's presented with that contingency, the animal is going to behave in a way that gets it as close as possible to its bliss point. So, of these five possible ways of behaving, of these five possible combinations of A responses and B responses, the theory predicts that the animal is going to settle on this one. It's going to pick option one here, basically. It's going to divide up its responses that way with about 100 A responses and 100 B responses because that's the best compromise that it can strike. That's the closest it can get to this ideal distribution that we call its bliss point. Okay. Now, notice in this case, we've restricted the animal's access to its preferred behavior, right? Response B. We've deprived the animal of being able to make that more probable behavior as much as it normally would. And so in this case, since the animal has to make response A before it can make response B, since it has to make that less probable response before it can make the more probable response, the more probable one has reinforced the less probable one. Response B has reinforced response A. So the animal is performing response A more now than it normally would, because that way it gets to make this response that it's been deprived of, response B, more often. But again, if we were to deprive the animal of the less probable response, if we were to deprive it of response A in this case, then we could make it reinforce the more probable behavior. So, for example, if we established a 10-to-1 contingency for this animal, if we set it up where this animal had to make 10 B responses before it can make one A response, which is more extreme than its natural 3-to-1 ratio between those responses, then in that case, response deprivation theory would predict that A, the less probable response, would reinforce B, the more probable one. So we'd see the animal increasing how much it made the B response until it got as close as possible to how much it normally wants to make the A response. Okay? So response deprivation theory or bliss point theory is definitely more complicated than the original Premack principle was. But it has the advantage of being able to explain why a less probable behavior can sometimes reinforce a more probable one. And research shows that it actually does a better job of predicting ahead of time what's going to be reinforcing for a given animal. So basically, we can define a reinforcer based on this theory as any behavior that an animal has been deprived of making as much as it normally wants to, regardless of whether that behavior normally occurs frequently with a high probability or rarely with a low probability. Whatever that naturally occurring baseline bliss point frequency of the behavior is, if the animal has been somehow deprived of performing the behavior at that frequency, then it'll find the opportunity to perform it to be reinforcing. Okay, well, I hope all that makes sense. But please let me know if you have any questions about response deprivation theory or this concept of a bliss point that response deprivation theory proposed. Okay, hope you have a great day.